Okay, today we're going to do one of the higher level, slightly higher. It's probably in the middle. It's on the harder side of the Calculus 1 related rate word problems. Now, the first thing I want to remind you of is the mnemonic device, which helps us to do word problems with related rates, which is DREADS. So that'll be diagram, rates, equation, derivative, and simplify specific amounts. But let's just write simplify because that's a lot of writing. Okay, now let me change colors here. All right, so what do we want to do first? We want to do a diagram. So what do we know? Okay, today we're doing a plane flying horizontally at an altitude of 1 mile and a speed of 500 miles per hour passes directly over a radar station. So we're going to need a radar station. We're going to need a plane, right? Find the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. So let's do our radar station first. I'll just do a little house. I know radar stations are round, but it's not that easy to draw. So we have a little house. This is our radar station. Okay, here's a radar. So we have a radar station and we have a plane, and we have a plane, and we have a plane that's directly over the radar station when we start, right? And we know that from the top of the plane to the radar station is 1 mile. 1 mile, because that is given right here. The altitude is 1 mile, okay? So we have the plane, and we know that the speed is 500 miles per hour. We know that the speed is 500 miles per hour, and the plane is going, and the plane is going, and the plane is going. And we want to know, and it's going at a rate of 500 miles per hour. We want to know when this length right here, when the plane is 2 miles away from the radar station. Let me just fix this. It's aesthetically annoying me. Okay. When the plane is here, right here, okay? At what rate does this distance increase when the plane is here, right? Well, what that means is, let's kind of make this a little bit clearer by making it a rectangle. We're only going to be using the triangle, but it just helps because this is the ground, and otherwise it's a little bit confusing. So this is our radar station. Let's call the sides some names, okay? So we know what we're doing. So first, what's this going to be? It's going to be, let's make it X. And then let's make this Z. And let's make this Y. Well, so we have the change of rate of X over the change of rate of time, right? We have the rate of change of X. We know that dx by dt is 500 miles per hour. That's important. We also know what Z is. We know that Z, or Z, depending on where you come from, is 1 mile. 1 mile. We also know that Y is 2 miles. We know Y is 2 miles. What don't we know? We do not know the length of X. We do not know the length of X and what we're actually supposed to find. So what we need to find to get to what we want to find in the end, we need to find the length of X. And our solution in the end is going to be the change of rate of Y, right? The change in Y over the change in time. That's what we want to find. Okay, so we know what we have. We know what we need to find. Let's get started on that. Once I can figure out my colors. Right here. Okay. So we need X. I'm going to go down here, and we're going to figure out what X is. What's the first thing that we notice? This is theoretically, obviously, this is not a very good sketch, but this is a right angle, right? Which means we can use the Pythagorean theorem. Well, this is the hypotenuse. It was supposed to be straight. It looks like an arc, but ignore that. So we know that y squared is z squared plus x squared. And we know two of those lengths. We know two of those, what those two of those variables are. We know that y is 2 miles and z is 1 mile. So we can solve for x. Well, that means that 2 squared is 1 squared plus x squared. And if we subtract 1 squared and square it, which is just 1, we actually get that x is the square root. Oh, there's supposed to be an equal sign there. I'm sorry. Is the square root of 4 minus 1, which is the square root of 3. We could simplify that. Let's not. What a pain, right? So, okay, so we know what it is. It's the square root of 3. So now we kind of have everything we need, because what do we do after we have the rates, right? We have the rates. Well, we have the equation because it's a triangle. We just used it to get x, but we can also use that for the end solution. We can use this right here for the end solution. And we're going to. So let's move over here to the right, and let's do our equation. We know that y squared equals z squared plus x squared, and we're looking for dy by dx, right? So it's okay, it's good. We have y on the left. Yes, it's squared, but that doesn't matter right now. What are we going to do? The derivative is next. The derivative is next, and we're going to use implicit differentiation and differentiate both sides. There are 3 variable mismatches here. So that means there are 3 chain rules here. And that is very important when you do these. You don't just have to derive the right side. You have to derive both sides, right? So you're going to have dy squared by dt, because it's the change in time, right? It's per hour, is dz squared by dt plus dx squared by dt. Well, what do we do? Chain rule on all 3 of them, right? So we're going to differentiate y squared with respect to y and multiply that by by dy by dt. And we're going to do it with z and x. I could say it 3 times, but it's a mouthful, so I'm just going to do it instead. So let's move over here. We're going to end up with 2y times the rate of change of y equals 2z times the rate of change of z plus 2x times the rate of change of x. Okay. Well, we're almost at the finish line because we almost have what we need. We need to now put in our values, right? So we're actually going to end up with 2 times 2 times dy by dt. Sorry, x is my go-to, but it's t. The variable is t in this one. Is 2 times 1 times the change in rate in z. And the change in rate, just give me 1 second actually. The change in rate in z should really be 0. And the reason is going to be, okay. Oh, right. Okay, I see why it's going to be 0. I see why it's going to be 0, but we're not there yet. So let's just write it down right now. Plus 2 times the square root of 3 times dx by dt. We know that dx by dt is 500 miles per hour, but we're going to put that in a minute, right? Let's do the rest first. What else do we know now that we're doing this? Well, we know that the derivative of a constant right here, right? We know that z is 1, and the derivative of 1 is 0. Well, so this all becomes 0, right? This all becomes 0. And we also know that this is 500 miles per hour. So this entire thing becomes 0. And the reason, it's 2, but it's 2 times 0, and that's just 0. So we end up with 4 dy by dt equals 0 plus 2 square root 3 times 500 miles per hour. I'm running out of space, but that's okay. I can make it work. And also, if you hear rain in the background, it is raining. So we're going to divide by 4, right? We're going to divide by 4 so that we can solve for dy by dt. And we're going to end up with 2 square root 3 times 500 miles per hour over 4. And that is going to simplify to square root 3, because you can 2 over 4 simplifies to 1/2, right? So you can make that 1 and you can make that 2. And but actually, you don't have to. You could do it an easier way. Instead of doing that, you could leave the 4, just multiply it, and then you're going to end up with square root 3 times 1,000 miles per hour over 4. And then you can just divide the 1,000 by 4, which actually makes life a lot easier. And you actually end up with 250 square root 3 miles per hour. And that is our solution.